Hi, this is Dr. Nick from the ECG Academy with the next Rhythm Chalk Talk. This is number 8. Now, I've labeled this as basic because this is an arrhythmia that you will see fairly often. This ECG isn't that hard to interpret, but I'm going to talk about some other physiologic and electrocardiographic ideas that might help you understand other tracings in the future. After all, that's what we're trying to do, is give you some practice in reading some of these advanced tracings. So we'll get to it. This is a bit of a departure from my usual rhythm strip because I'm showing you the whole 12 lead. But down here there is lead 2, which is a rhythm strip that you can kind of take a look at. Look at the whole forest, and you can see that it's a little slow in the beginning, and then it seemed to speed up a little, and then it gets slow again at the end. So that gives you an idea that the rhythm may be changing here. So let's examine these ECG beats in detail. We can see an upright P wave in 1, 2, and 3, a normal PR interval of maybe 160 milliseconds, and then the QRS complex looks pretty normal. The T wave does as well. So now look at rate, and if we look at this S wave that lands on a heavy line, we can count off 300, 150, 100, 75, 60, 50. This is exactly 50 beats per minute. And so if the P wave is coming from the normal sinus region and we have 50 beats per minute, we can diagnose sinus bradycardia. Pretty simple, right? But if we go down to our rhythm strip, we can see that this third beat, something changes. The P wave looks different. It looks upside down. It's an inverted P wave in lead 2. And that kind of makes you think that the P wave is coming from somewhere else in the heart. After all, axis gives you an idea of direction. And if the P wave changes its axis, then usually that means the P wave is coming from a different spot in the atrium. So what else do we see? Well, let's bring up a pair of calipers and examine the rate. And if we bring this caliper down to the first beat, I've set it for 50 beats per minute, which is the P to P interval of the first beat. But if we bring this over, we can see not only does this P wave change its axis, but also comes a little bit early. And so this is an ectopic beat coming from some focus in the atrium. We're going to discuss that a little bit later. And if we take another pair of calipers that I've set for the P to P interval here, which if you count back, be about 300, 150, 175, 60, maybe 66 beats per minute, and you can see that the next P to P interval actually speeds up a little. And that so the rhythm kind of warms up. It goes from 66 to maybe 72 beats per minute. And then after this last beat here, stops, and then the normal P wave comes in after a bit of a pause. Okay, so get rid of our calipers and start talking about the P wave. Now, not only is it inverted in 2, but it's inverted in AVF, but it happens to be upright in AVL, which makes you think that it is headed from left to right. Well, what do you mean? I mean from right to left. Are we getting confused? Well, in that case, then why don't we look at axis and kind of review what axis is all about? Axis has to do with the vertical plane, or the so-called frontal plane, and it has to do with the limb leads. So we can divide up this 360-degree circle into equal parts, and the first leads 1, 2, and 3 are pretty simple. Lead 1 is going from right arm to left arm, and that's designated as 0 degrees. And then we have to divide with leads 2 and 3. We have to divide the circle up into equal parts. So where does 2 go? Well, 2, 3, and AVF are the inferior leads, so it's going to point towards the bottom part of the circle. But at what angle? Well, I always tell people to remember that in English we read from top down and from left to right. And so if you draw a line 60 degrees above the horizontal, because we do have to split the circle into 6 equal spaces, and this will be lead 2. And then, of course, lead 3 would be the last one. Since it's an inferior lead, it also points towards the bottom, so that's lead 3. And so you've got your first 3 limb leads in here with leads 1, 2, and 3. Now, where do the augmented limb leads go? Well, AVF, which is also an inferior lead, goes straight down, and that's where plus 90 degrees is. Let's see, this is AVF, and that's plus 90 degrees. AVL is going to point towards the left arm, so that comes up here. And then AVR is the only one sort of like kind of an odd lead because it sort of points in the opposite direction than all the other leads combined. That's why most signals are negative in AVR, because P waves and QRSs tend to point down and to the left towards the apex, and that's going away from AVR. So when a signal is going in the opposite direction than a lead, let's say AVR, if the signal is going down and to the left away from AVR, then it's going to be drawn as a negative deflection on the ECG. All right, so what does that mean in terms of our P wave? Well, here is, let's just erase this, and here's a drawing that I made of the heart. And here's your sinus node up in the right atrium. Your left atrium is a little bit higher than that and to the left, but when the sinus node fires, the signal spreads to the left and down, which is why P waves in a normal sinus rhythm tend to be positive in the inferior leads, and they're also positive in 1 and AVL, because the signal is traveling towards 1 and AVL towards the left. But now in this ECG, what you see is that the P waves are negative in 2 and they're positive in AVR. That means that this signal, this P wave, is arising from some crazy place. It likely is arising from the low right atrium somewhere, because it's heading towards AVL, where it was positive, the P wave was positive in AVL, but it's also positive in AVR. So it's traveling in those two directions, and of course it's going away from 2-3 and AVF. It's arising from the low right atrium and traveling towards the head. So that tells us that's an ectopic focus somewhere in the low right atrium that takes over the rhythm. Well, let's go back to this and see what we're talking about. So you have this, by definition, an ectopic atrial rhythm. An ectopic atrial rhythm that is a little bit faster than the sinus bradycardia that's here. The P wave changes because the axis of the P wave is headed up and towards the right, but it's also positive in AVL, so that's why I think it's coming from the right atrium, since it's going towards AVL as well as towards AVR. So you have this ectopic atrial rhythm that has a little bit of a warm-up, because it starts out sort of slow and then builds up a little bit. But then after this ends, you have a fairly long pause. And that's pretty common, because we have this concept of overdrive suppression. Overdrive suppression is an electrophysiologic concept that any area in the heart, whether it be in the atrium or the AV node or Purkinje fibers or even ventricular myocardium, is able to fire. It's able to deliver electrical signals. It has something called automaticity. But if another region of the heart is firing faster, then that automaticity is suppressed. That's why you don't have these ectopic atrial beats all the time, because the sinus node usually keeps them suppressed, because the sinus node tends to fire faster. But here, what do we have? We have a sinus bradycardia. It's very fast. It's very slow, I mean to say. And so that allows some of these ectopic atrial foci to gain footing and create these arrhythmia problems. But when the ectopic atrial focus stops firing, then it takes a little while for the sinus node to kick in again, because of overdrive suppression of the sinus node. We see this commonly in sick sinus syndrome, where you have a tachyarrhythmia and then post-tachycardia pauses. The common cause of lightheadedness in patients with tachybrady syndrome. All right, so I think the other thing to point out is that in this 12 lead, you do have an RSR prime pattern in V2, a little bit of it in V1, but the QRS complex isn't wide enough to really qualify for a bundle branch block, but this allows you to diagnose an incomplete right bundle branch block. All right, so what you have is sinus bradycardia with a run of an ectopic atrial rhythm that has a little bit of a warm-up there, and an incomplete right bundle branch block on the 12 lead that is worth mentioning, and a little bit of a sinus pause after this arrhythmia that's probably due to overdrive suppression, and this patient may be on medications or may have a degree of sinus node dysfunction, but it's a common presentation in someone who may have symptoms. On the other hand, it may be asymptomatic, so you have to take the patient as an individual. Anyway, I hope this was interesting to you. I hope I've clarified some concepts in terms of axis and rhythm, and I enjoyed showing this to you. And remember, log on to ecgacademy.com so you can watch videos from basic to advanced, and you too can become an ECG expert. Oh, and subscribe to my YouTube channel so that you get notified when I put up my next Chalk Talk, which will be soon. Keep watching, and thanks for viewing.